Hi everyone, this is a video tutorial on creational design patterns. So what are the design patterns? Design patterns are solutions to common problems that arise in software development that were developed by experts. There is a famous book called Design Patterns, Elements of Reusable Object-Oriented Software, and that book describes 23 design patterns. And there are many kinds of design patterns. For example, creational design patterns that deal with object creation, such as factory method pattern. Structural design patterns that are concerned with how objects form larger structures within the application, such as composite pattern. And behavioral design patterns that identify communication patterns between objects. For example, command pattern. This tutorial describes and provides examples of creational patterns: Singleton pattern, factory method pattern, and object pool pattern. And we'll be looking at implementation of those patterns on an example of shape drawing program. So let's begin. So let's have a look first at the Singleton pattern. So Singleton refers to a pattern where we want to create only one object of a given class. And we also want to make sure that the object is globally accessible within the program. But you might ask, why not just create a static class? So Singleton class, it is more versatile than a static class. It can also implement interfaces and extend other classes. So let's have a look at our shape drawing program. So in our shape drawing, we had a drawing class. So that class was holding a collection of shapes. And the program only requires one instance of that class. So it would be good to make sure that only one instance of that class can exist within the application, particularly if we want to extend the application in future and create more functionalities and add more classes to it. So that way we want to make sure that no other part of the program can create and instantiate another drawing class. So how would we implement this type of logic? So first of all, our constructor is made private. So we can't create an instantiation of the class from any other class. We have a private constructor. And we also have a private class variable that is declared, so we can refer to that one instance of the class. And we have a public method, getInstance, that creates one instance of the class if it doesn't already exist. So let's have a look how we can do this in our shape drawing program. So we have a private constructor, so that's private drawing. And we have a private class variable drawing instance, and at first we set it to null. And then we declare our public method getInstance. So that public method, what it does, it checks if our drawing instance is null. And if it's null, then we create a new drawing. And we return that drawing instance. And if it's not null, that means that we already have an instance of our class. So this logic ensures that only one instance of drawing exists. So how do we use this? So when we go to our game method file, we can use this getInstance method to create one single instance of the class. We'll say drawing, my drawing, equals to drawing.getInstance. And that way, we have one instance of the class. Now let's have a look at another creational design pattern, and it's a factory method pattern. So the idea behind a factory method is to create a class that has a purpose of just creating objects. Like a factory in real life, which purpose is to create things. Similarly, in a factory method pattern, we have a factory class. And it creates objects based on the input type. So when would we use like a factory method pattern? So factory is useful when we have one superclass, such as shape class, and it has multiple subclasses like rectangle, circle, line, and such and such. And based on the user input, we need to return a particular object of a specific subclass. So that is the scenario that we have in our shape drawing program. So let's have a look. So how do we implement this factory method pattern? So we create a shape factory class that has create shape method that returns the shape that we need. So we have here public method create shape. It returns a shape, and we have as a parameter we have a shape type that indicates what kind of shape we want to create. So we create here a shape which is first equal to null, and then depending on the shape type we will create a particular shape. For example, if its shape type is rectangle, then we create a rectangle and we return the rectangle. If it's a circle, then we create a circle. If it's a line, then we create a line and we return that shape. So we can see that using this factory method pattern makes our software more maintainable. If, for example, in the future we have 5 more shapes or 10 more shapes, we can easily add this logic to the create shape method. And it makes code easier to maintain and more scalable. So what we now how we use this in our main game main file, we create a reference to the shape factory, say factory, and then when we need to create a shape, we'll just say shape new shape equals to factory create shape, and we pass kind to add as a parameter to create the particular type of shape that we want in the program. So that's pretty much overview of the factory method pattern. Now let's have a look at another pattern that is often used in games development, and it's object pool pattern. So the idea behind the object pool pattern is to create a pool class that we can use to store objects and reuse objects instead of allocating and freeing objects every time when we need an object. And the benefit of object pool pattern is that it improves memory performance. So what we do is we declare a pool object that holds the collection of objects that we need. So then when we need an object, we ask the pool for it. And once the object is no longer needed, it is returned to the pool. So this particular pattern is used in games development, for example, when we have shooting bullets or shooting projectiles type of behavior or type of scenario. So then when we shoot a bullet, we borrow it, grab it from the pool, and when we don't need it, we return it back to the pool, and then again, when we need it, we grab it from the pool, and so on. So let's have a look how we can implement object pool pattern. I'm going to show an example of object pool pattern in the shape drawing program. So if we remember the shape drawing program, it draws shapes and then deletes the shapes. So what we can do is create a pool of shapes, and when the shape is deleted, it is returned to the pool and can be reused again. So let's have a look. So first of all, we create a Singleton shape pool class that contains a list of objects that we want to store in a pool. So we only want one pool, one shape pool in our program, so that's why it's a Singleton class. So here we have our shape pool class with a list of shapes, and we can specify, for example, capacity of one shape, just for now, in the beginning, as a private constructor. And the constructor is using getNewShape method that creates a shape that we need for the pool. And it uses factory to create those shapes. So we have this getNewShape. It returns a particular shape that we need. And then we have two other methods. So getShape method, it returns a shape from the pool. So what happens is it first checks, is the pool empty? So if pool isn't empty, then it returns the last shape that was added to the pool. So if we check if pool.count more than 0 is more than 0, then we actually grab the last shape and we just return it. And if the pool is empty, then we create a new shape, increase the pool capacity, and return that shape. And we also have here return shape method. So that method is used when we no longer need a shape and we want to put it back into the pool. So we pass shape as a parameter and then add it to the pool. So these are main methods that we need for the implementation of the object pool pattern. So get shape, return shape, get a new shape, and the constructor. So let's see how this works on our shape drawing program. So we create a shape pool in the shape drawing program. So we have here shape pool variable, and then we get the instance of the shape pool, one single instance there. And then when we need to create a shape, when the left mouse button is clicked, we'll just say new shape equals to shape pool get shape. So we're grabbing a shape from the pool, basically. And what we also now need to do is change the remove select shapes method. So remove selected shapes method, initially it would just remove all the shapes, but now what we want to do is before removing the shapes, we'll return the shapes to the pool. So if the shape is selected, we just say pool return shape, and we pass the pool as a parameter to that method. So that's pretty much what we can change in our shape drawing program. So, and that way we implement the object pool. So that way when we delete shapes, they return back to the pool. When we create new shapes, they are actually obtained from the pool. But now we've noticed that this object pool pattern, it actually creates a different behavior in our shape drawing program. So at first, it works the same way as before. We can just draw different shapes. But now what happens? Once the shape is removed, it's moved back to the pool. So when we create a new shape, that previously deleted shape will actually reappear in the same spot because we're actually grabbing that old shape from the pool. So let's just see how it works. So I'm just going to run my shape drawing program. So we can draw our rectangles, we can draw our circles, we can draw our lines. And now, let's say we click on the circle, we delete it. We click on rectangle, we delete it. And we click on another rectangle, we delete it. So now let's say I want to create more shapes. So I click somewhere and we can see that's the last shape that we put in the pool. We are reusing that shape. So it's back in the spot. And that shape is back in the spot. Now this shape is back in the spot. So now I can create more shapes. So this way we can see that we have implemented the object pool pattern. It does introduce new behavior, but we can definitely see that we can reuse the shapes. And that way we can use this pattern for future programs, like for example in games development when we need to shoot bullets or have other resources that we want to reuse instead of always creating and allocating memory and then freeing the memory each time. So this concludes my tutorial on the design patterns, creational design patterns that we had a look at, Singleton, factory method, and object pool pattern. Thanks very much.